Good afternoon, all of you. Omkar, am I audible?
Yes, ma'am.
So today we will start with module 4. We have already started with module 4 in previous two lectures. Now module 4, 5 and 6, as I have told you, is all about the applications of machine learning in cybersecurity. So we have started with few applications in the previous lectures, and today we will focus on network anomaly detection using K-means algorithm, and then how to proceed with the stages of network attack with the help of K-means algorithm for anomaly detection. So we have already seen that what are the different stages of anomaly detection, what are the different types, okay, in the previous few lectures. What is intrusion detection? So here, what are the challenges? We'll quickly revise these things and then we will go for the algorithms which can be best suited for anomaly detection in general. Then we will talk about K-means algorithm, which is prescribed in your syllabus, especially for anomaly detection. So as we have seen, intrusion detection, this is the process of monitoring the events which are occurring in a computer system or network, which are used to analyze them for intrusions. So we have different types of systems which are incorporated to create data for intrusion detection system. And it is very much necessary to set the real working environment to explore all the possibilities of attacks, which is expensive. And the software which we use to detect network intrusions, it protects the computer network from some unauthorized users, including the insiders also. The intrusion detection learning task is actually to build a predictive model, that is to use a classifier which will be capable of distinguishing between bad connections, which are called as intrusions or attacks, and some good normal connections. Now, to prevent this problem in network sectors, we have to predict whether the connection is attacked or not from any particular data set using machine learning techniques. So here we have to use some machine learning techniques for better packet connection transfers, which will be able to forecast the prediction results in best accuracy. So there are various algorithms which we have seen till now. Okay, so we have used the different types of algorithms for solving numericals. Now we have to apply all those algorithms on the application of anomaly detection. So we will see one by one all the types. Also, we have seen the challenges. So we have seen the traditional signature based IDS system. These are based on signatures of the known attacks, so it cannot detect emerging cyber threats. So your supervised learning model will become a challenge here. Then substantial latency in the deployment of newly created signatures across the computer system. Here, anomaly detection can alleviate all these limitations. So the challenges we have already seen in the previous lectures. We are just revising now. Now, fraud detection can also be referred as one kind of anomaly detection. This refers to detection of criminal activities which are occurring in commercial organizations. So, here it is also known as identity theft, that are the malicious users. They might be the actual customers of the organizations, or they might not be the actual customers and posing as the customers. So they can create the frauds, types of frauds. You all know it can be a credit card fraud, insurance claim fraud, mobile or cell phone fraud, or insider trading. So all these types of frauds can be there. Now the challenge is here to build a machine learning model for these fraud detection techniques are these are all fast and accurate systems of real time detection. So this becomes a challenge to have the data set for these fastly changing and accurate real-time detection techniques. So misclassification cost can be very high if you do not use the correct classifier in these cases. So these are the challenges for the fraud detection techniques. So what can be the strategies? So we have seen these three types as the learning models till now. It can be supervisory, it can be semi-supervisory, or it can be unsupervised anomaly detection. Now, when we have supervised anomaly detection, the labels are available for both normal data as well as for the anomalies. These are similar to rare class mining techniques. Semi-supervised, the labels available are only for the normal data, but it cannot predict something which comes out of the box. Unsupervised anomaly detection, the labels are assumed. Okay, there are no labels which are indicated as such, but they are based on the patterns or some assumptions that the anomalies are very rare compared to the normal data. So we have these three types for anomaly detection. So here you can see the classification based on all the techniques which we have seen. So it can be contextual anomaly detection or collective based online anomaly detection or distributed anomaly detection. If you go point anomaly detection, then we have all these algorithms which we have seen. In classification based, we have rule based algorithms, then neural network based, your ANN and RNN, then SVM based, support vector machine. We have nearest neighborhood. In that, we have density based or distance based. Then clustering in unsupervised learning, statistical, parametric or non parametric. And there are many more like information theory based or spectral decomposition based or visualization based. There are many more algorithms which exist in literature. We'll see classification based techniques. Now, when you have to build a classification model for normal and anomalous data, which are the rare events based on labeled training data, you have to use it to classify each new unseen event. So classification models, they must be able to handle the skewed class distributions also. Okay, so here, for example, you have some intrusion detection systems where you have to have a software application to detect network intrusion. So in that case, what is the task of IDS? The task of IDS is to monitor a network or a system for malicious activities and then protect a computer network from unauthorized access from users. Okay, so here you have to get proper data sets. So what is the data set used in general for the intrusion detection systems? You have KDD CUP 1999 data set, that is a very famous data set which is used, KDD CUP 1999. So you have various data files in that, list of features, then you have full data sets available for the intrusion, list of all intrusion types. Okay, so all these are the data set features in that. Then duration, what is that? Flag for the error status. Okay, so all these are the features available in the data set. So all these features you should be able to take properly. And then only you will be able to classify it according to the skewed class distributions. Then we have few categories which we have seen, supervised and semi-supervised. In supervised, you have to have the knowledge of both normal and anomaly class. And then you will build the classifier to distinguish between normal and known anomalies. Then you have semi-supervised classification techniques. You require the knowledge of normal class only here, and then you have to use modified classification model to learn the normal behavior and then detect any deviations from normal behavior. So whether you have some difference in the normal and the at that instant, what do you find? So that is called as difference in the normal behavior. You tag it as anomaly. And what are the advantages of these classification based techniques? So when you go for supervised classification based, the models can be easily understood. They are easy, less complex, high accuracy in detecting many kinds of known anomalies. When you go for semi-supervised, the models can be easily understood. Normal behavior, you can accurately learn from that, or anomaly can be tagged easily. But at the same time, there are few drawbacks. in supervised classification, the drawback is it requires both the labels from normal class as well as from anomaly class. And it cannot detect unknown and emerging anomalies. So that is the drawback of supervised classification. In semi-supervised, it requires the labels from normal class, and possible high false alarm rate is one of the drawback of the semi-supervised technique. Then we have rule-based techniques. Here you have to attempt to define a set of rules that can be used to decide that a given behavior is that of an intruder. Okay, so there are various techniques available, like you have the SNOT tool which is available, which is a flexible open source NIDS environment. So you can use the benefits of signature protocol and anomaly based inspection here. So these are some tools which can be used directly for your network intrusion detection systems. Okay, and then you can have it as a de facto standard for intrusion prevention system as well. So these are some rule based techniques which are available here. You can also go for neural network model for the anomaly detection. So here you have to train the neural network to predict user's next action or command given the window of previous action. So whatever has happened in history, that you have to give, and then the neural network will be able to predict what will be the next action. Here the advantages are they can easily cope up with noisy data. Success will not depend on any statistical assumption about the nature of the underlying data, and they are easier to modify for new user communities. But you have problem of small window, and it results in false positives. Large window will result in irrelevant data as well as increase with the chance of false negatives. The intruder can train the net during its learning phase. That is also one of the disadvantage here. And the net topology is only determined after considerable trial and error. These are all drawbacks here. Accordingly, you can use multi-layer perceptrons or auto-associative neural networks. You can use RNNs, replicator neural networks. So all these strategies can be used for anomaly detection. So here you can see the RNN, replicator neural network. So it is using a replicator 4-layer feed-forward neural network. Okay, see how many layers are there. When you are using RNN for the neural network, RNN neural network for the anomaly detection, what all things you have to understand? What are the input variables and output variables? So how the model can remain compressed, that care you have to take. So that is very much important. Okay, these are designed for time series data. So you have to check that whether they are suited for implementation on the flight deck to provide real-time anomaly detection. Okay, so all these things you have to understand in case of RNN. You have done one model in practical systems on perceptron. So you can try building a perceptron for this also, for anomaly detection. So any abnormal behavior which will be a live detection kind of thing, that you can have with the help of RNN. So people have a lot of research they have made on the RNNs for network traffic anomaly detection, right? So you can take help of few citations which are there on RNN based, And then you can make your own strategies that which algorithms will be best suited. Fine. Then people are customizing, making alternative approach so that the known malicious behavior patterns can be able to detect. The model can be able to detect, as well as it can be able to detect the previously unseen patterns also. Okay. So all these things you have to strategize that which all algorithms can be used for which different applications. Then people are using something called as auto encoders also. So these are nothing but neural networks which are learning on a low dimensional representation of given input. And they consist of encoders and decoders as the inputs, fine, where they can be used to represent the input data. The encoder network, it will iteratively learn different data compression functions. Okay, so these are also some of the strategies which are available to detect the anomalies. Then another strategy can be using SVM, support vector machines. So here you are converting it into one class classification problem. So you have to separate the entire set of training data from the origin. That is, you have to find a small region where most of the data lies and then label the data points in this region as one class. Okay, so as we have seen in SVM, how the hyperplane can be created. Okay, so you have to push the hyperplane away from the origin as much as possible. So here you can see in this diagram. Then you have to separate the regions containing data from the regions which are containing no data. Right? So this is the challenge here in SVM. Then you have nearest neighborhood based techniques. So this we are going to see today. Okay. Nearest neighborhood based techniques. What is the key assumption which you have to make? The normal points, they have close neighbors, while anomalies are located far from the other points. Okay, so you have to take two-step approach. First, you have to compute the neighborhood for each data record. Then you have to analyze the neighborhood to determine whether the data record is anomaly or not. So you have two categories in the neighborhood. You have distance-based methods or you have density-based methods. In distance-based method, the anomalies are the data points which are most distant from the other points. And in density-based methods, the anomalies are the data points in low density regions. Okay, so you have to check that which kind of detection is there. So if you have k nearest neighbor algorithm which you have to use, then it measures the distance between a query scenario and a set of scenarios which are there in data set. So then you have to compute the distance between the two scenarios using some distance function. Okay, so you can have the absolute distance measuring scheme or you can have Euclidean distance measuring scheme. Fine. So that you can give to the data set. So your model of KNN can become the entire training data set. And when a prediction is required for unseen data instance, the KNN algorithm can search through training data set for the K most similar instances. Okay, so this is how the KNN algorithm can be used. In that case, the prediction attribute of the most similar instances can be summarized and returned as the prediction for the unseen instances. Okay, so you have again different types of KNN like instance-based algorithms or competitive learning algorithms. So instance-based, when it is, then the model, you have to model the problem using data instances in order to make predictive decisions. Right, so you can see KNN algorithm is extreme form of instance-based method because all training observations are retained as a part of model here. You have few advantages as well as the drawbacks for nearest neighbor-based techniques. Advantages in the sense it can be used in both the techniques without labels or with tags. that is in semi-supervised or unsupervised learning models. Here, you do not have to make any assumptions about the data distributions. Your entire set can go under training data set also. Drawbacks: if the normal points do not have sufficient number of neighbors, the techniques may fail, and it will be computationally expensive case in that. In high dimensional spaces, the data is sparse and the concept of similarity may not be meaningful anymore. So, due to sparseness, the distance between any two data records may become quite similar, and each data record may be considered as potential outliers. And in the previous class, we have seen to handle the outliers, either you have to remove the outliers or you have to cap the outliers, okay, or else you have to replace the outliers. But in the whole thing, you will see that the values are going to change. So that becomes one drawback. Now, under the two techniques of nearest neighborhood, we have distance based. So in distance based, we will see what are the steps for implementation. First, for each data point D, you have to compute the distance to the kth nearest neighbor. Then sort all the data points according to the distance. You have to check the outliers which are there. So outliers we have seen, these are the points that have largest distance and therefore they are located in the sparse neighborhoods. So you have to use a parameter n, usually the data points that have top n% distance, then dk are defined as outliers. After nearest neighborhood based techniques, we have clustering based techniques also for anomaly detection. Here we have to make certain assumptions. That is, normal data records, they belong to large and dense clusters, while anomalies belong, they actually do not belong to any of the clusters or form very small clusters. Categorization according to labels. So here you have two types, semi-supervised or unsupervised. In semi-supervised, you have to cluster the normal data to create modes of normal behavior. And if a new instance does not belong to any of the clusters or it is not closer to any cluster, it is tagged as anomaly. Okay. Then in unsupervised also, the same case, you have to check the size of the cluster and the distance from the clusters, and then you have to post process the data. Now, what are the advantages and drawbacks of clustering based techniques? Here, the advantage is you do not need to be supervised always. Okay, you do not require any history, some labels which are to be used in case of supervised learning model. Also, it is easily adaptable to online or incremental mode, which is suitable for anomaly detection from temporal data. Drawbacks: yes, it is computationally expensive. So, you have to use some other methods of indexing structures to reduce this problem or to remove this problem. Then, if normal points do not create any clusters, the techniques may fail. So, this is one of the drawback again. Now, these techniques you have not learned till now. We have learned only neighborhood. Then you have learned the clustering techniques. You have learned different types of semi-supervised learning techniques. Apart from that, you have statistical based techniques also. Something based on the data statistics. So here, the data points are modeled using stochastic distribution points, and they are determined to be outliers depending on their relation with the model. So here the advantage is we can utilize existing statistical modeling techniques to model various types of distributions, but with high dimensions, it becomes difficult to estimate the distributions. These are the drawbacks or the challenges of statistics based techniques. So here are the two techniques of statistical strategies. You have parametric or non-parametric technique. In parametric technique, you have to assume that the normal and possibly anomalous data is generated from underlying parametric distribution. Then you have to learn the parameters from the normal sample and then determine the likelihood of a test instance to be generated from this distribution to detect anomalies. In non-parametric techniques, you don't have to assume any knowledge of parameters. You have to use non-parametric techniques to learn the distribution. Okay, so this is one example which can be used for non-parametric technique, that is Pearson window estimation. Okay, so here we have seen different techniques of anomaly detection. Fine. Now, suppose you have to go for network traffic anomaly detection using RNN. Okay, so in that case, which different strategies you can use, which different algorithms can be used. So you are going to think on this again for 5 minutes, and then we will discuss which algorithms can be best suited for network traffic anomaly detection, which is the next topic in module 4. Okay, we have done up to anomaly detection, then feature engineering. We have done with anomaly detection with data and algorithms, challenges of using machine learning in anomaly detection, and the building a predictive model to classify the network attacks. Now, what is left is using k-means also. I have shown you the different stages which you can go for network anomaly detection. Now, what is left is the network traffic analysis and how to define the theory of dense network defense. Okay, so these things are left from module 4. Now, before going to that, I want you to think on which different models or which different algorithms can be applied for anomaly detection and network traffic analysis. Okay, so think for 5 minutes on this, and then again we will discuss which algorithm is best suited for this thing, and which modules from Python you can use for anomaly detection, which data sets you have to use for anomaly detection. Think of all these techniques. Till now we have seen different algorithms. We have used naive Bayes, decision tree, random forest, SVM, logistic regression. So which type you can use for the for capturing the traffic features? Okay, so that you have to think. What kind of data pre-processing will be required? I have given you one example of the data set which you can take. That is KDD cup. Okay, this you can take as the data set. For anomaly data set, you can take KDD cup. Then you can pick up all the features which are there in KDD cup data set.